So in this class we are going to discuss about diffraction. So diffraction is bending of waves around the sharp edges into the geometrically shaded region. So the bending of waves around the obstacles is diffraction, but diffraction is violates the rectilinear propagation of light. So rectilinear propagation means straight line motion of light, but diffraction is more prominently pronounced when the size of the obstacle that is equal to that wavelength of light used. So that is visible light. So 400 nanometer to 800 nanometer. So this is a range from violet to red. So size of the obstacle in the range of 400 nanometer to 800 nanometer, diffraction will occur in the case of light. So if it is a sound waves, so sound waves get diffracted in doors, windows and buildings because the wavelength of sound is somewhat large compared to this geometry of the obstacles. So diffraction is bending of waves around the sharp edges, that is geometrically shaded region, that is around the sharp edges of the obstacles. Then there are two types of diffraction here discussed: Fresnel diffraction and Fraunhofer diffraction. So Fresnel diffraction, so this spherical or cylindrical wavefront is diffracted. If it is Fraunhofer, that is plane wavefront is diffracted. Here source is at finite distance in Fresnel diffraction. Here source is at infinity. So source is at infinity means we get the plane wavefront. So if it is at finite distance, you will get the spherical wavefront or cylindrical wavefront. So there is no need of that convex lens if it is for lab condition. So there is a need of convex lens for Fraunhofer diffraction. Though it is difficult to observe and analyze in case of Fresnel diffraction, so it is more easy to observe and analyze in case of Fraunhofer diffraction. So this is an experimental setup. So there is a slit. So source is finite distance. So here this is a slit, this is a screen. So this is difficult to observe. So here there are two convex lenses are used here. So this is a slit. So source is at infinity. So there is need of convex lens to focus to the slit. So to get the result, there is a need of another convex lens. So it's a screen at the point B. So in this class we have discussed, so what's my diffraction, that is bending of waves around the sharp edges. So diffraction occurs only the size of the obstacle is comparable to the wavelength of light used. So Fresnel and Fraunhofer diffraction, so that is source is at finite, here infinite, that is infinity. Here the spherical or cylindrical wavefront is diffracted, here plane wavefront is diffracted. So this is easy, that is difficult to observe and analyze. Here Fraunhofer is easy to observe